So in this session at GroupBy, Greg is going to be talking about how Stack Overflow uses SQL Server. So Greg, take it away.
Cool. So my name's Greg. I'm joining from Salt Lake City, Utah today. I do want to say thanks to Brent for organizing this, as well as the community for upvoting this session. I'm excited to be able to give this talk. So we're going to talk a little bit about how SQL Server is used to keep Stack Overflow and the rest of our network online. You can see the agenda here. Do need to give a disclaimer. This is very heavily biased towards the needs of a very large .NET-based website. So please don't take anything I say as hard or fast truths. They definitely are not. But I hope you'll find some interesting tidbits in there. Also, working for Stack Overflow is like drinking from a fire hose every day. So there's a lot of information packed into these slides. I do not expect to cover everything, but happy to follow up offline. So if you see something you're interested in, ping me, whatever. We'll start a good conversation, hopefully. Hopefully, a lot of you are familiar with Stack Overflow. I definitely know I use it every day, and we believe most of the world's developers do as well, at least on a monthly basis. We actually run a network of about 162 different Q&A communities from very wide-ranging topics, from bicycles to DBA. There's a DBA specific, dba.stackexchange.com. Kind of a really cool network of sites to be able to be a part of. Last summer, we released a new content type we're calling documentation, which is focused on code examples. Still pretty early in the beta process there, but there's already 100 topics on the SQL Server tag. Highly recommend you go and check it out if you haven't looked at that yet. We do, of course, also have a job board. It's one of the ways we pay for servers and salaries. And then recently released what we're calling developer stories. It's kind of an alternative to a resume. Great place to go and show off some of maybe the cool things you've been able to do and accomplish. A few numbers. Site rankings, of course, vary quite drastically based off of who's measuring and what they measure, but safe to say we're in the top 50 sites for the US, probably even closer towards top 25. Fairly decent amount of traffic nowadays, 108 million global uniques a month, 1.3 billion page views. Those are probably already even outdated from the last time I updated the slides. The sites were launched in 2008. Good history link there from, I believe, a Channel 9 video that was recently done by Joel Spolsky. We were always built using SQL Server, IIS, and ASP.NET, which is a technology stack you don't often see at that size and scale. We do also have a fair amount of other technologies in the mix, and then we use a Fastly CDN as our edge cache provider. A few more numbers, 17 million questions, 27 million answers, over about 44,000 tags or topics. And one of the cool ones is about 20 billion SQL Server queries each month. So we definitely get a lot of value out of those licenses we pay for. And some more interesting stuff, there's about 10 top-level domains and a lot of subdomains. We're currently in the process of trying to move everything over to HTTPS and finding all the quirks and concerns around doing that correctly. And then we do have 360 databases that all use the exact same schema and data tables, and we have to keep those in sync as they change frequently. It's actually 2 per each site, one for the primary Q&A and one for the meta for that community. So kind of an interesting problem, and we'll show you a bit about how we do data migrations. And then another cool thing, all of our user-generated content is licensed under CC by SA. So it's a really cool place. If you want to get it in bulk, you can do that through archive.org. There's a Kaggle data set available if you're doing some machine learning queries. We just recently got set up with Google BigQuery, so you can do some stuff on their Bigtable, BigQuery stuff, and some nice guy named Brent even made an MDF LDF download. If you want to use the SQL Server database and some demos or whatnot, to go grab that. It's a great real-world data set that you can go play with. And we love our community. They're very technical. Often when there are bug reports, they'll actually include fixes for CSS or JavaScript, which is just an amazing thing to have happen. So myself, I am on the SRE team. Basically our job to keep the sites online, make sure they're running fast, secure. We have an on-call rotation, rotates through about 10 different people now, I think. We maintain all of our internal hardware and services, which is a mix of Windows and Linux systems, almost half and half. Pretty much all of our production traffic is served off of physical hardware. We're not a very big virtualized or don't have a lot of cloud services. Pretty much all we use is Glacier storage for offsite encrypted backups, and then Route 53 GCE for DNS. Those are kind of the two main cloud things we use. Everything else handled through a data center in New York for the most part. We very much enjoy talking about this stuff publicly. It's actually part of our annual review process. We kind of get graded on it. We have a blog off of the server fault domain. You can see here, this is from about 2 years ago when we did an upgrade of a live data center. Lots of hardware porn if you're interested in those kind of pictures, or just seeing some of the maybe behind scenes things, how those work. Also contribute to the company's engineering section of the Stack Overflow blog. We maintain the Stack Status account for Twitter and off of Tumblr. If we ever have outages or do postmortems, there's a cool one that got recognized on Hacker News about a regex that took down our sites for a little while. It's kind of fun to see some of those horror stories sometimes. Then lots of people on our teams and development team have personal blogs, Twitter accounts. We've done a few AMAs. Definitely like to be involved as much as we can in the community. The SRE team works very, very closely with the developers, so we're not in charge of the core code. We do a fair amount of development for like automating tasks that we have to work on, but we make sure that development teams, they can do streamlined deployments, any sort of troubleshooting, security, performance, that kind of stuff. We definitely work with them very, very closely. So to get into our SQL Server strategy, software engineering projects can sometimes devolve into Rube Goldberg style machines. We try to avoid those as much as possible. We try usually the simplest solution we can find and eliminate any excess complexity to hopefully end up with something that will scale. That's a problem that we've had in our history as we've seen our traffic grow significantly since that initial launch, and we found simple systems just generally scale much, much easier, and of course are much easier to troubleshoot when things go wrong, and they always go wrong. So we also try to make things as fast as possible. So we try to render pages in 10 to 20 milliseconds, which is sometimes difficult, but it's usually achievable, especially if you have access to optimize the full stack all the way down to the hardware. At our scale, fast rendering can actually increase productivity of the world's developers. So when you accumulate it, it can save countless days or weeks of developers' lives, and it's something we enjoy. Whenever we're looking for a problem, getting that solved as fast as we can. So we do, of course, need to make sure we're highly available and have disaster recovery strategy in mind. We do live maintenance in the primary data center. If we ever have to go down, it does disrupt global developers. You can see it on Twitter. It's one of our best monitoring systems. If we have an outage, my tweet deck column will just blow up usually 10 to 20 seconds before any alerts. It's just crazy to watch. So we try to avoid that if at all possible. We, of course, have DR plans for everything. We monitor everything we can, often from multiple locations, so we'll show you some of the systems we use. And then when we're designing, say, our data access layer, we try to centralize things into OMR features if it's something we think the public might be able to use. We'll talk about Dapper a little bit, which is our micro ORM. And then definitely lots of caching and making troubleshooting a first-class feature is pretty important for us. So primary workload, we do have 2 main clusters and 5 availability groups across those, about 369 databases total. Like I said, 2 for each site, and then various databases for other services. Those 2 clusters are composed of 2 Windows server failover clusters with 3 nodes each. There's a primary in New York for writes, a replica in New York for reads, and then a replica in Colorado for disaster recovery. You can see here we're actually currently using Windows Server 2012, not even 2012 R2. We're kind of stuck on that until we can figure out the most efficient way of moving to a new cluster without tearing down the whole thing. We'll talk about that a little bit. Not crazy hardware, definitely some big boxes, but just a Dell R720, Dell R730. We try to operate on about a 4-year hardware lifespan, so the Stack Overflow cluster is actually up for renewal. We're speccing that out right now. Hopefully we'll have it replaced in the next few months here with the latest and greatest. In total, Stack Overflow cluster has about 3 terabytes of data, and the Stack Exchange cluster has about 4 terabytes of data, all running off of NVMe SSDs for the most part, with some additional either SSDs or hard drives backing it for some maybe slower, less IOPS needed. We do have some additional SQL workloads. I'm not going to dive into these too much, but we have a decent data warehouse now where we send all of our traffic logs. There's actually 2 separate standalone instances of that. We'll replicate the logs to both, we'll send copies to both New York and Colorado. 80 terabytes uncompressed, 20 gigs raw daily that it's growing by. Great for troubleshooting, machine learning, various things. Our ad server and data science teams are doing great work with column stores in 2016. There's been some major performance gains in storage. Won't be talking about it now, but hopefully there'll be a session on column store in the future for GroupBy because there's some amazing things going on there.
Raul's already, and a couple of people have pulled it. They said, "Did I read RAID 0 on that last slide?"
We'll get into that. It's one of the trade-offs we'll do, and we'll maybe explain why. And not, like I said, not best practice, but it is a RAID 0. We have a lot of things that will lean towards performance, and we'll show some of those reasons why. So,
and also,
go
Eric wanted to throw in and ask. He said, "What do you do with your old hardware? And is there any way I can come pick it up in New York City for free?"
So we have the original data center was in Oregon, so we actually have 3 data centers. We'll send a lot of the old hardware to Oregon and make a great test lab. If we need to spin up some new systems, play with some decent gear, we'll do it there. Sometimes occasionally we'll get sent out to employees. I don't think we've ever done to the public though, so there's a long line waiting for some of those, I think. Another place that you can access our data is through data.stackexchange.com. It's actually a public-facing site built off of the Stack Exchange Data Explorer open source project. Great place to go and explore SQL without having to use SSMS. There's all the site databases are there with just some columns and tables removed, so it's not displaying private information. You can see on the right a dashboard from OpServer, which I'll show a bunch of screenshots of today, and various miscellaneous servers. We do try to keep our CPU low because that's almost always the first resource we'll run out of. And then for data.stackexchange, an example of our kind of simple process, instead of using SSIS for ETL, we actually just use stored procedures and SQL jobs to kind of shuffle data around. We found it to be a simpler process. We didn't need the full stack, and that tool set was kind of too big for our needs. We just went with a more simple approach. So some HADR concerns. Why we're using RAID 0? Well, we do have redundancy at a hardware level. So back in 2012, which was way before my time at Stack, the team actually worked with Brent to move over from 2008 to 2012 so we could get access to AGs. They've been a key part of our strategy since. There's a great blog post if you want to see some of that history of how we moved and what we're using those for. We're not only RAID 0, we're also asynchronous commit mode. So with our data, we value the lower transaction latency over the slightly larger window of potential data loss. And then, of course, we can switch between those modes if we need to. So when we're doing a manual failover, we'll go from asynchronous commit to synchronous and be able to do that without any data loss. And then it is, like I mentioned, split between the 2 clusters. AGs are great because they support things like rolling upgrades with minimal downtime. Most of that time is actually spent spinning up the listener IP and waiting for our .NET connection pools to stabilize. When we're doing a failover, we'll actually shunt the traffic at the load balancer, do the flip, let things kind of stabilize, come back up, and then re-allow traffic to go through. That's currently the best solution we found. Maybe some ways to improve that, but it works for our needs and is a fairly straightforward, simple approach. So again, the 2 different AGs, or the 2 different clusters, the primary one only has 1 AG, but the Stack Exchange network cluster has 4 because that is the failover unit, and then you can do different characteristics on them. So we'll have one that's a higher SLA for, say, our ad server or machine learning kind of money-making operations. Maybe one that doesn't go out to Colorado, so we have New York only databases that don't need to be replicated. Chat is an important one because that is a very critical system during an outage. We might want to fail that over independently to the DR site, so we can do that by giving it its own AG, and then SE network just holds all of the rest. And we can see here the OpServer view of all of the replication traffic, how big the logs are backing up on servers if there were any issues, rates and whatnot. So we'll be going through a few more of those screens during the monitoring section. A few more of our experiences with AGs. We do like them because they let us use simple and fast local storage. We're using Intel NVMe PD3608s, I believe, and they are in RAID 0. We have data redundancy at the server level. We've yet to have one of these go out on us, knock on wood, and we like that we can get the better performance. We can trade off that performance versus slightly higher risk, and just hasn't been an issue for us. We actually end up replacing them every 18 to 24 months anyways, as we need to grow into additional storage. So definitely don't recommend RAID 0 unless you've thought through all of the different concerns, but we have a lot of other ways of making sure that we have redundancy at either a server level or through backups and whatnot. And it's kind of interesting, those drives are actually 4 terabyte drives, but they're presented as 2 by 2 terabyte. So in the current system we had, we couldn't even really do various RAID systems. We couldn't do a RAID 10 because it wasn't available through the hardware controller. We only really had what Windows software RAID could provide for us, and that was going to be a RAID 0 or RAID 1. Now on the newer server, we have been able to get Intel's latest RSTE drivers to do basically hardware RAID, and so on our new dev servers, we're specing out some different things. Maybe we won't be RAID 0, but it's worked fairly well for us so far. We can also use the replicas to scale out the read traffic by sending application intent read-only in our connection string. So that'll let us do read operations on that replica, and it's great at scaling out our load across the 2 servers. And if we ever needed to, we could split that out into additional servers through the AG if needed. If you've never worked with AGs or failover clustering, if you are using multiple sites where you have to span across multiple subnets, those clusters can be kind of rough to deal with. We actually had fairly frequent issues when we were using VPN tunnels for replication. Adding a dedicated MPLS connection helps significantly, so you do want to make sure you have as much stable connectivity between the 2 as possible. But it's still somewhat fragile, especially with our 2012 server OS. Been a lot of improvements, so if you're able to, definitely recommend using 2016. They've done vast improvements in the clustering, but our long-term plan would be to move to a new feature called Distributed AGs in 2016, because that'll mitigate the multiple subnet failover issues. You'll actually have an AG of AGs and don't have to do these kind of cross-site boundaries that can sometimes be difficult. So currently, our #1 performance blocker is the speed of light. Rendering pages in less than 10 milliseconds doesn't really help if somebody's in Australia, 200 millisecond round trip time. The Fastly CDN can help somewhat with caching static content or dynamic requests, but our question pages have a fairly long tail, like 80% of them are viewed every month. So one way we could get around that, we've been planning and would love to try to implement if we had the time or money, would be creating a global point of presence where we can put Stack Overflow in a 2U server and put one on each continent, and then use distributed AGs to keep the local replica in sync with the primary data center. That'll handle all of the read workload, and any write requests we could just forward to the main data center. Great technology, and we love that, again, things that can scale all the way down to a simple local VM setup will scale all the way up to attacking the speed of light. So it's a great technology for us to kind of base our business needs on. Distributed AGs are also a great way to do data consolidation. So we have those 2 clusters, and we've always wanted to create reporting instances, but because they're on separate clusters, we would have usually had to actually create 2 reporting instances because we couldn't find easy ways of getting the data to go into one instance. But we could do that with AGs. We could have distributed AGs that kind of collapse that information down into one database, offloading a lot of the batch requests, preventing a rogue query from being able to harm production. So this is my favorite topic, is monitoring. We're somewhat fanatical about our monitoring systems. We actually usually end up building our own, so we get exactly what we want. And then we also do run multiple instances of it. So we'll have a copy of OpServer and a copy of Bosun in each data center, so they're accessible even in the case of major failures. So this is the main view of OpServer, which is our single pane of glass dashboard. Shows the status of all of our various different systems. It's an open source project written by Nick Graver. Kind of has a very heavy SQL focus, so you'll see a lot of these examples of screenshots here in a bit. It was originally backed by the Orion monitoring system and their monitoring agents, but the latest version now uses our Bosun monitoring system instead. It will let us do automation of various things like Redis failovers or putting a server in maintenance mode for Haproxy, overriding on-call if I'm doing some risky operation and my colleague in New York or Alaska, I don't want to wake them up. I can just take on-call to make sure it doesn't call them. It'll call me instead if I screw something up. And again, all the high-level characteristics, you can see our SQL servers usually run fairly low. In this case, we did have one going up to 21% CPU, which for us is kind of a high, it's a warning level of CPU usage. We try to keep those low so that if there is some sort of influx, if we get attacked by a DOS attack or various things, if we screw up, hopefully we have enough overhead that we can survive that without having to, we can't spin up new instances like some cloud providers can. We have to make sure we bake in with a reasonable amount of overhead if possible. Similar view for Redis. Hopefully any information I need to know about how to manage or monitor Redis is going to be available directly here through this view. The AGs that you saw screenshots of before, if there were things that were going wrong, of course, they're going to turn red. It will show us which databases aren't in sync, and we can kind of watch those catch up as we hopefully address or resolve whatever issue was causing the problem there. And this is the main SQL instance view. So you can see things like trace flags and performance metrics and various other operational things you might want to look into. If there is a problem, again, we'll try to turn it red. In fact, we try to turn the entire tab red if there's a problem with an underlying component, so you can even just see in the top right corner what's going on at a high level. So if I were to click on that job that is red, it'll show us an outline of all the different jobs we have on the system. We have various jobs for replicating SQL logins across the cluster, T-log, full backups, optimizations and checks. On another server, we actually, on our utility SQL instance, we'll restore those nightly backups because, backups don't fail. It's the restore that fails. So make sure you're testing those. After it's done restoring that, it'll even go through and do what we call a sanitize minimize process. There's a stored procedure written by the dev teams. It'll run that process after the full backup. It creates a smaller version of the database that we then save off to a storage or to a share, and they can use that for development and testing. So we do that every night. We're testing not only our backup process, but also getting sanitized minimized versions for developers to use. So this is a nice wall of numbers that you get if you ever go and look at the top tab. It shows all of the top queries that are running and lets you sort by various things. So by default, we're sorting here on the average execution of CPU time per minute, but you can then also change it to say total. So if you want to see the accumulated CPU used by each query, this is how we can track down if there's a problem with one of our SQL queries very quickly. When you hover over a query, you're going to get the text for that query, and you can see there's a little special comment that we've added in, and we'll talk about in the developer section a bit. You could also change it to do total executions or executions per minute, filtered down by database or some other execution counts. And then when you select it, you're going to get the full query plan so that we don't even have to go into SMS to find that if we're deep in checking out what's causing our SQL Server to become slow. So this is a great tab. Can be a little intimidating when you open it up and just hit with a wall of numbers, but once you get used to it, it's a great tool to have access to readily right from a web browser. Be able to share this with other developers. A lot of our teams are remote, so you can't have somebody looking over your shoulder. You got to be able to share that with them in a quick and easy fashion. We also do include Atom Mechanics, SP Who's Active, so that's a great way of seeing if there's something that's having lock issues or causing other resource waits. We can hopefully find that quickly and easily directly from this tab. And then a view of the open connections, so the logins, what host it's from, also what isolation mode they're running in. If the developer is connected and trying to run a query in the wrong isolation mode, we can track them down and prevent them from causing any locks through their ad hoc queries.
Lots of people are saying that they're trying to open OpServer now. Just keep in mind that GitHub is experiencing a major system outage. This is not anything with like a bad link. GitHub's having a huge outage right now. So
yeah.
nothing to do with your link.
It'll still be there, and it might take some time getting it set up. So I'll show you all the screenshots, and then you can hopefully have some fun trying to get it set up later today once GitHub's working again. Also, a reason why we don't use GitHub for our product, right? We use a internal GitLab instance, because if this kind of thing were happening and we couldn't do deploys, that's a scary thing to be in as a sysadmin or SRE. So. Here's the database tab. So this shows for an instance the databases that are running on that server, the state that they're in, is if it's synchronized or having some other sort of issue, sizes, various other details. And then when you select it, you'll be able to dig down into tables, columns, various information about all of those. Some features we haven't added in yet towards the bottom of the left-hand side there, but definitely a great way to be able to dive in deeply to these kinds of information, again, through a browser, not having to open up SMS, being able to deep link colleagues and whatnot to information when we need to share it across team members. So Bosun is a monitoring system. We're kind of crazy enough to write our own. Don't recommend it, but try ours. It's open source. So it has an S-collector agent that uses WMI to collect information from IIS and SQL, Windows, various other systems. We don't currently access any DMV values directly from S-collector, but in the future we'll probably scrape that information out of OpServer. It already has all of it. We don't need to double dip. We can just kind of grab the information OpServer has and then store that into a time series database. Makes it great being able to look back historically. Right now we're using OpenTSDB, but it also supports Graphite and InfluxDB as kind of the major time series databases, and being able to retain a history of operational metrics has been invaluable in our experience, especially when things go wrong and we might not even notice it for 6 months or 9 months, and be able to go back and identify when that occurred. You can see here at the top there's an active alert that hasn't even been acknowledged yet, so it's kind of hopefully something new that has occurred. When you expand these out, they'd actually even show the template of the notification that would have been sent. There's things that have been silenced, so if we're doing maintenance on a host or it's an understood issue, we can silence it to prevent it from bubbling up an alert. And then once it goes inactive, it would still retain on our dashboard, because we kind of want to do root cause analysis, figure out why it happened. Maybe we need to tweak an alert if it wasn't, it was kind of a false positive. So this is one of the views that we use to track down that information. The graph tab on Bolson is what we use to explore the time series metrics. It will generate expressions as you're going through and filling in the various fields, and then you can take those expressions and turn them into alerts combined with the notification templates, so that you kind of progressively go through and go from ad hoc query searching through to generating hopefully finely tuned alerts that will give you all the information you need when that error occurs. The boxes at the top were a feature that was added last year. It is system-generated or human-generated annotations. So if we have a server reboot, we have it send itself an annotation so we can see when that occurs. If we have an outage, we can mark that with a box so that we can identify it even across various different metrics. Outages, maintenance windows, those kind of things. We found it very, very helpful. We actually just store them off in Elastic. It's a fairly simple thing to set up, and it's the graphs will support scrubbing. So during postmortems, we can kind of get detailed time windows of how long something occurred, and it's just been a great tool. I spend a lot of time in this kind of thing, just researching, trying to find high signal metrics and turning them into alerts.
Nice.
Yeah, so Redis, this is actually even about a year old now. So at last February, we were posted this on Twitter from Nick, and we did about 160 billion Redis operations. And all the time, the top of that graph is 2.2% CPU usage. So this thing is really good at, it's a key value store. Anytime we do an expensive operation, we'll usually cache it in Redis. Our internal data access library uses the public stackexchange.redis NuGet package to create what we refer to as an L2 global cache. So Redis is accessible from all of our servers, and we can cache anything that we want at kind of a global level there, but then we'll also cache it in a local ASP.NET cache called like an L1 local cache. So when we go out to SQL, we will take that information, put it in the L1 cache so that server can reuse it if it needs it again in a short window, and then also into the L2 cache so that if any other servers in the web farm need it, they should also have access to it pretty readily. And here on the left, we can see the template from a Bosun notification. So if I was to get an alert at 3 o'clock in the morning, I want as much information in that so I can hopefully analyze it with as few brain cells as maybe I have at that point in time. And in this case, it's saying there's high CPU usage on a system and that the process is called Crushinator. Well, I happen to know that is our ad server simulator, so I'm not too concerned about it. It's on a machine learning box, not going to be affecting production. I can ignore it and deal with it at a later time if need be. And then on the right-hand side, you can see some of the various different kind of chat-opsy things we're able to do. If we have a spike in exceptions, we have a fairly complex alert that will actually post that into various chat rooms. It'll tell us not only which data center is having the spike, if it's New York or Colorado, but then it will also break down application count. So here it's saying stackexchange.com, which is actually a different code base than stackoverflow.com. Or API. It'll break it down by host and kind of give us as much information as we can cram into a little short text message. For us, it's actually the developers that will go through and look at that. We'll see that in a bit when we talk about some of the developer principles. And then others will have different flavors. So here's malfunctioning Eddie in our ad server teams room. They have their own, quirks on their chatbots sometimes. And then the ability to create those annotations, so those blocks on the graph. If I'm doing an upgrade on a SQL server, I can just type that out into a chat message, and the Bolson bot will come back and say, hey, I created this annotation for you. I can go in and edit it more if I need to. The next one I want to talk about briefly is Grafana. The main thing I can say, if you're not already using it, you probably should be. It's by far the best thing we've seen to be able to create dashboards. Pull data from a number of different sources, including Bosun, which we use primarily, but also Elastic and directly OpenTSDB is where most of our time series data lives right now. This is what a SQL Server AG dashboard looks like, showing an issue with our Windows failover clustering kind of just failing and not coming back. But our dev teams also use this, so they'll go in and create their own dashboards for their application. And it's been a very valuable tool. So if you're looking to do any sort of dashboarding, we didn't even do any real dashboards in Bosun because we didn't feel the need. We could just rely on Grafana to create those for us. We don't have to duplicate their efforts. It's a great open source project to start.
Matan Youngman asks a question. He says, do you have any suggestions on the best or quickest way to learn and start using the Grafana stack?
So that is a good question. For us, it's mainly just going in and see what works for you. They did recently add the ability to share dashboards. So there should now be, I think they originally called them data sources, which was like the ability to just get the data out. And now they've come up with what they call applications. That's kind of a higher level construct. And it might include a fully fleshed out dashboard for you. So if you look into, instead of just the data source plugins, see what applications are out there, they're starting to show up more and more. I believe they even have kind of like a gallery view where if you want to see what somebody else did for SQL Server or some other product, you can definitely find what they did and hopefully just copy it. I've seen it float around on a few various places too. Some of the subreddits that I follow, somebody will come up and say, hey, here's the Grafana dashboard I created. So it really does tie into where your data lives. Sometimes that means you might need to start with more of like the influx tick stack to get up and running and get data into a system. But if you already have an existing monitoring system, hopefully Grafana supports it. If it doesn't, then yeah, go from there. And for us, it's just been an evolution as we've continued working on this over the last 3 or 4 years. So. But it's pretty easy to get started with your first dashboard. Like that's, hopefully you'll find at least one place you can get information. They even have, I believe they call it Rain Tank is the company, and World Ping is like their external ping all of your stuff service, and they will integrate that directly into Grafana. So if you're just looking for something to ping your website and make sure it's working, that's a fairly easy way to get started. And then here's another view of that same dashboard. This is what one bad SQL query making its way into production looks like at Stack Overflow. Things kind of just explode. when we have an issue like this, what we'll usually do is we'll start an OpServer and try to figure out or isolate which component is having the issue, and then dive down into a specific dashboard for that system. During a postmortem, we'll look back through the series of metrics and see what we were overlooking, and then we'll add that to an existing dashboard or create a new one if we found that we don't really have one that's sufficient. And then go through and find if there's a high signal metric that we could create an alert out of, or something that predicted a warning or failure characteristics. So a lot of times you won't know exactly what you need until you have some sort of anomalous event, but once you do, by having that time series data, you can go back, look through it, and hopefully make it so that next time that won't happen, or you get much faster resolution when it does. So the last section that we're going to talk about is the development principles. It's kind of a lot of information, so we'll see how much of it we can get through. Looks like we're doing pretty well on time, so I'll go through as much as I can. A lot of these are, I just kind of wanted to throw it in because it has to be a full spectrum. You can't just work on SQL problems. You got to make sure it's also the development teams and that everybody's kind of on the same boat. And we'll show you some of the ways that we've been able to achieve that at Stack Overflow. Definitely one of the first ones is just communication. You can't have silos of ops versus dev. You gotta work as teams. In our structure, we actually have 2 people that are on the SRE team that are also they're actually full-time developers as well, so they are kind of bridges between various different product teams. It's worked out really well, but we'll also do things like when we're going through and planning a SQL upgrade, we'll make sure that they're aware of how that upgrade is going to impact them. When we do the upgrade on our production systems, we do need to bring the developers and the build pipeline with us because they're using backups, as we talked about, those minimal backups. As soon as we flip the switch to 2016, now their entire local setup also has to be 2016. So I know Bob talked this morning about some of the cool things in 2016. Developers, we wanted to make sure they were aware of what they were getting. There's some cool improvements in SSMS. It's not based on an archaic shell of 2010 anymore. It's at least upgraded to the Visual Studio 2015, which does add a lot of improvements. And then the live query statistics are an amazing feature if you haven't seen them yet. They're even available in downstream versions like 2014 SP1. So it's a great way of being able, if you're troubleshooting a query, you don't have to wait for the whole thing to finish. You can kind of watch it fill in the statistics as you're going. And then, they did get some new features from the language perspective. String split was an interesting one. We actually found that it was the fastest way of getting a large list of information embedded into a query. So between JSON and string split and various other methods of splitting an integer into an in array, so where exists in or whatnot, our data access layer needs to do that fairly frequently, and if we can find ways of improving that in Dapper, everybody is going to get the benefit for it. So there's some cool information there. It was a great blog post on the SQL Performance blog about string split follow-up to, I think was the name of it, and just some amazing stuff, being able to go through and benchmark it. Definitely not going to be a win in all scenarios, so you need to see what's working best for your specific situation, but kind of a cool thing to be able to pass on to developers and show how they're getting improvements just by when we upgrade to 2016. And then simple things like if exists and drop and alter. Developers love being able to have shorthand on those kinds of things. JSON is a big feature in T-SQL. I know a lot of people are very excited about it. We do definitely make use of it in very particular places. We use for JSON when we're doing ad hoc data migration. So if we have a bunch of columns that we kind of are wanting to just turn into a blob because maybe they're changing or it's not really a static schema and we just want to make it a more fungible JSON object, and we can do that through the for JSON T-SQL statements now. We also do use OpenJSON and JSON query to then extract information out of those columns in some points, but we're not going to do it in our hot path. SQL Server CPU is definitely the most expensive thing in our data center. We have 2 or 4 SQL servers. We have 9 web servers, and they're much more capable of doing that kind of work. So in our hot path, we're probably not going to use SQL to manipulate JSON, but if we need to, if we're doing data migrations or various other things, previously we would have had to do like maybe a developer route in our application that only they can access, or use a third-party tool like LinkPad. It's a great tool we've used for abusing in many different ways. But now we can do some of those things in SSMS. So very good to have it available, but it shouldn't be something that you're always looking at just using directly. In our case, we definitely have more computation power on our web tier than we would in SQL, and definitely also cost less to do it there. Here's the exception log that mentioned earlier. So it's been very beneficial when we have all of our applications, make sure that they collect all of their exceptions from all different parts, be it a SQL exception that was occurred or various other things, and centralize that into one location. Because when we have something break, it might be that it manifests itself through various different systems, and we need to track down what the actual root cause was. It's also just one of the highest signals that we've ever had been able to grasp. This is the primary thing that developers will look at when they're doing new deploys. We do not have a dedicated DBA team. All of the developers are responsible for writing their own SQL and then monitoring it during those deployments. The deployments are staged, so they would start by, of course, working on their local system. And once that's ready, they'll move to a private shared developer environment and do some additional testing there. There's a dev exception log that they can look at to try to see if they're creating any problems there. We would then move to what we refer to as the public meta sites. So it's a portion of our public-facing properties that we can kind of abuse. They're actually our most engaged users, so they'll always find the problems before anybody else was, and we would much prefer to have something break there before it rolls out to Stack Overflow and the rest of the network. So finding a way of doing those staged deployments is another key component of our deployment process, and we'll find countless things on Meta that never cause issues on the wider network, and hopefully we're finding them on local or dev the majority of the time, but sometimes they'll slip through, and we'll still be able to find them there. By having those applications use Stack Exchange Exceptional and putting everything into a centralized place, we can then manage them in bulk. We'll do duplicate detection so that you can just see a count over there on the right-hand side. That number 2 usually is more like 2,000 if we have a real issue where it's going to be the same thing occurring. We can quickly identify what the problem is and go from there. Since there are multiple teams, there's some. This is a fairly recent addition to OpServer where you can then filter down by not only team but then also product within the team and kind of see that breakdown. And then on the left-hand side, you can see the X's and lock icons, which actually show if you want to clear out information. You can do that by selecting similar or kind of all of this category, or just clear the whole thing, because sometimes you just got to commit exception bankruptcy and start over. But if you're going to do that, but there's a few you want to save, you can just lock them. That way you can say, oh, well, I really need such and such to look at this, but they're not awake yet, so I'll save this for later and then be able to share it to them with a URL. Again, a web-based product, being able to do link sharing is amazing versus SSMS or event logs. Trying to get that information into somebody else's hands can sometimes be pretty difficult. So. We mentioned database migrations. So there are a lot of products that do this. I've used dbGhost and various Redgate products before to handle database change management. Definitely want to find the right one for your specific scenario. For our scenario, it was hundreds of sites that run the same schema and need to be updated. We found using multiple databases is more advantageous than trying to consolidate it all into one, because we'll have Stack Overflow that's a 3 terabyte or 2 terabyte database, and then we'll have Bicycles or whatever the newest beta site is that's a few megs, and we don't know what's going to happen to those sites. One of them might explode, and if it gets incredibly popular and we need to give it additional resources, using a database to isolate that means we can move it to a different server, kind of manage it as needed. Not all of the sites survive. Sometimes they get closed, and so we need to be able to clear those out, and being able to export the data to a data dump and then just delete the database, we found to be a very reasonable process. It's not uncommon for things like a WordPress hosting site. They're going to have a very similar situation, and they might just have a bunch of copies of databases. SQL Server can handle that just fine. So needing to solve the migration problem, we found just including SQL migration scripts in a folder in the Git repo has been the simplest approach, and then a very small tool that will run that across all sites during one of the stages of the build process. You can see at the top there, that's Team City is what we use for managing various different builds in our systems. It found 342 sites that it was going to go through and update. We do design those scripts to be idempotent, so if it's an especially large one and we can't run it within the time limits of our build process, we might actually run that on Stack Overflow beforehand. We can run that through SSMS. When it then goes through to check the script again, it's going to just go through and see it doesn't need to do any work. Worked out pretty well. In fact, one of our developers, Brett Copeland from our ad server team, liked it so much he wanted to be able to use it on public projects. So he created an open source version. It's called Mayflower.net. It's not the same one we use in our production, but it's kind of a simplified version of it. So definitely something you can look at, see if it works for what you're doing. If it doesn't, modify it to your own needs. It's another simple approach to a problem and has worked out reasonably well for us. This is actually an interesting snippet of SQL here. So it's for what we're calling the census badge. It's awarded, it's another one of the virtual badges I talked about earlier, to people that take the developer survey, which I believe launched yesterday. So if you want some virtual swag, you can take the 2017 developer survey that was just recently announced on stackoverflow.blog, and you will get what we're calling the census badge if you're willing to add in your Stack Overflow account number into the survey results that they'll go through and use. Okay, so Dapper is a micro ORM. Many of you may be more familiar with Link to SQL or Entity Framework. They all have pluses and minuses. You should never go out and just try to use something because somebody says it's the best. We've found Dapper is great at being a minimal and thin layer that does very simple things, but can be built up to become as complex as you need it to become. So its main goal is to be a wrapper around the IDB connection object, and then take string text that is just embedded into your code base and turn that into a query that gets executed. And then returns just plain old CLR objects. Very, very simple approach. It lets us do things, optimize it at kind of a lower level, so like that parameterized list thing we talked about using string splits. And then in our code base, our SQL mapper extensions will do sufficiently more complex things like building up the SQL query. And when we're building up the query, we know the line number that was executing that, and we can embed inside of the query something like controller/method at line number. That is by far the most useful thing I've ever seen in any database, is when you look at the query, it tells you where it was being executed from. It means when it has a problem, I can go and find it immediately. I don't even have to really understand the code base. I can just kind of see where it's coming from. So that's been the approach that we've seen. Definitely the benefits of it is having that full control over the query text. If you've ever had to look at Link to SQL or Entity Framework queries, they can be quite cryptic, and they're often poor performing because you don't always have full control over what the framework is trying to do for you. Whereas taking a simplified approach, you do end up having to write more code, but you get more control over it as well. And being simple, it should be fairly easy to get started with it. If you're just writing SQL queries right now, you should be able to take your existing queries and just wrap them into this thin layer of ORM to get a few niceties out of it that you can then keep building on top of. But because it is just strings, they're not strongly typed. So if you're needing to have some more of the compile time checks in place, then Dapper might not be the best place to do it, or you might need to combine it with maybe you'd only use stored procedures to pull information into Dapper, and you can still get those compile time checks through other SSDT tools maybe.
Riley asked a question. He says, so he knows from looking at the pages that it says the number of views that each question has, things like that. He said, well, since you log read counts, is anything really read-only, or do you separate the logging of views from the alteration of content?
Yep, we would definitely separate that out. So those paths are highly optimized, and can be done separately, right? So we don't need to increment that view count immediately. We could definitely batch that up if need be. We could, in fact, if we were cloud provider, we might just send that off into a queue, let it accumulate for 5 or 10 minutes, and then update it at another point in time. So by being able to separate that out, we can render even if you're logged in, we could render still the bulk of that page in a fairly cacheable format and just send some one-off operations. In fact, a lot of that information is coming to us through a WebSocket, which is a technology that it's not an AJAX request. It's actually kind of a back and forth communication between your browser and one of our servers. So those WebSockets could easily exist in a writable data center, and the rest of the stuff, half the time, it may just be rendered directly from the edge. Our Fastly CDN could render the bulk of that because it had cached that object with a certain key, and then the write operations might even take a completely different channel and just it's just combined on your screen using JavaScript, which is kind of the magic of the web, which is pretty cool. But one place that we definitely have difficulty using Dapper is in those complex relationships. So if you do have a lot of child objects or dependencies based off of things, multiple tables, you're going to have to do a lot of work to get that to operate in Dapper. And in fact, we've, from a legacy standpoint, had a lot of link to SQL. We're looking at Entity Framework, especially the VNext, that has a lot more capable development models as ways of managing that complexity for our limited, lower volume write operations. So we get the high performance of Dapper for the read-only page views, and then a simpler approach to updating data through Entity Framework or link to SQL. So if we can keep the maintenance cost down of having those two systems, that is probably our preferred approach. We don't want to turn Dapper into the full framework ORM. We want to let Entity Framework do what it does best, which is managing those kinds of relationships and some of the more complex operations, and then let Dapper handle things that are easier to manage. Okay, and this is one of the last slides we have for our development process, which is, again, the full pipeline, being able to make sure we're measuring not only things that are occurring within our data center, but how is it actually affecting our end users. So one of the main ways that we do that is through something called MiniProfiler. When one of our developers visits the website, which we do on a monthly basis, just like everyone else, trying to solve our own problems, they're actually going to get a drop-down on the top right corner, and that's going to say how long that page took to render, and breaks down the entire rendering pipeline from the various MVC stages to third-party things like calls out to SQL or Redis or ElasticSearch. It's going to break that all down into hopefully easy to understand and look at information. Like here it's saying a certain section took 149 seconds. You can see it even turned red because the total was 192, whereas we're expecting that to be much closer towards 20 milliseconds. It's a great tool. It does require you to instrumentalize your views. You're not going to get any of this really for free, except the lower level ASP.NET stuff. Sometimes we can kind of tap in and get for free, but then you're going to have to go and say, okay, well, I'm going to do this section of work, so let me wrap it in something that will time it and send that information out to it. We can then, again, pass this information around. There's a shareable link that we can use. So if we see a problem, we can say, hey, it looks like this is taking longer than others. And it's one of the main ways we really see performance degradation on our sites is when we're using it. If we see it's being slow, we just can in one click check to see why it's running slow and then start tracking down that problem. And that's great for us, but again, it's only available for developers on the site. That's a much smaller sample than the world at large. So we also do something which is the client-side timings of the browsers that are visiting the page. They've been in browsers for quite a while now that you can just ask it for information about how long a DNS lookup took, how long the HTTP negotiation or DOM manipulation took. There's a vast amount of information that's available. And so if you go to test.overflow.com, it'll actually break that down and show you the information that we're collecting. And we'll just collect that for a small sample of users. We only need 1% or 2% of our page views to to show that information to us, and that'll give us information from across the world. So we'll understand, is there some sort of regional issue maybe, which kind of indicates maybe a problem with our CDN. It's another piece of information that we'll throw into our data warehouse so that we can go through and crunch the numbers. In fact, when we were changing CDN providers from Cloudflare to Fastly, we made extensive use of that. Also doing things like putting a hidden iframe, so we can do testing of DNS providers on an alternate domain and just get access to huge volumes of very valuable information. I believe the latest blog post on Server Fault goes through and talks about that, how we measured different DNS providers, chose the best ones, and then also showed how we could combine two of them so that we don't have an issue if Route 53 goes down like Dyn DNS had recently. That was a major critical failure in some infrastructure that we hopefully think we can work around by just using two of them, but are we going to have any performance degradation? Well, we can measure that beforehand using some of these tools. So definitely, if you're doing web development, these are the kinds of things you need to try to work on to get access to that data. You're always going to hopefully have more data than you can consume, but just having access to it will help you make much better, more informed decisions. And so that's kind of wrapping up for the material that we had. There are a lot of open source projects that we contribute to, and we do have a list of them there. The two big ones that I was talking about today was OpServer, single pane of glass dashboard, and then Bosun, our monitoring system. If you're interested in some more of some of maybe the development aspects than just the SQL, one of our developers on our core team, Marco, did recently do a presentation at JSConf in Asia, and that's something I would definitely recommend looking at if you're interested in. And then Nick Craver has an amazing series of blog posts. If you're wanting to know about our infrastructure, his blog is one of the great resources to see about the things that we do. And then he also had a recent podcast on MS Dev Show. And then just today I saw my boss, Kyle, had a presentation on Bolson from Graphonicon last December. So if you're also interested in learning more about Bolson, there was a Monotrama video from a few years ago, and it sounds like just another brand new one recently for Graphonicon. So, and that's all I have. So happy to take any additional questions and go from there.
Woohoo! Well, first, before we go into questions, I want to thank Greg for volunteering to speak here at GroupBy and sharing what Stack Overflow does and what lessons they've learned. I know in the Slack channel we've been already talking about, thanks for being so open with everything. Slava asks, how many questions have you posted on Stack Overflow along the way? I'm guessing that's more of a rhetorical.
Yeah, I mean, I've posted quite a lot. The one I would actually be interested in, how many have I read? There's an interesting feature. So our machine learning is called Providence, and if you look through the blog posts about when we release Providence, if you are a signed-in user, or even if you're not, it does track those, and it will at least tell you the tags that you've visited, and it will try to predict what kind of a person you are. So for myself, it's seen that I'm visiting a lot of, say, SQL tags and maybe some things that go towards DevOps, so it might label me as a sysadmin or a DevOps user. And so it's going to use that information to maybe change what kind of ads it shows me. But you can go and download that information. So if you go into your profile and say, hey, send me my Providence profile, it'll tell you all that information. You can go see exactly how many questions you've looked at and what tags they were on. It's sometimes kind of interesting, and even more so, you can see how you've changed over time. And if you're at a different job using different technologies, it's really cool to be able to see how that goes. So there is a place on our site I could go and look up that information, and I've looked through it a few times. Recently, it's been the DBA site. If I find a complex problem that I can't solve, I'll usually post it there, and then if I later do solve it, I'll fill in the information, because half the time, 4 years later, I'm going to forget what I did, and I want to have that public artifact to go back and find it.
It's the same reason I got started blogging too. I'm like, I got to write this stuff down because I know it's like my documentation. Andrea says, with your availability groups, how do you guys keep logins, jobs, and linked servers synced between all of the nodes?
Yeah, and that is one of the SQL jobs that we have does a login replication. It's kind of unfortunate it's not provided in a more standard format by Microsoft, but I can kind of see that maybe there's some differentiation there that's hard to make generic. So for us, we just have a SQL job. It will be able to go through and get the information of what logins should be on that server, and it will create those. So as soon as we create it on the primary, within usually 10 or 15 minutes, that job will run, and it will run on all the servers and let it replicate out. Logins or link servers, we don't make extensive use of. Actually, I guess we do have in a fair number of places, but they're fairly static. We haven't had them change a lot. So we just have a big spreadsheet of how do we set up a new SQL server, and it just gets added in there. Things like installing various sort procedures too for SP Blitz and all the goodies that you can get onto a server nowadays. So.
Jay West asked a question. He came late. He saw the slides on AGs. Is this multiple instances on the same server with AGs on each instance? Is that possible? No, SQL Server won't let you do AGs between the same physical box. Mark V asks, he says, you mentioned you're speccing out new hardware. What are some items on your wish list? Are you going to post the specs, and when is it going to be finalized?
Yeah, we're mainly looking at the latest version of the R730 chassis again. So primarily, we actually don't need to do the upgrade. It's more that we either need to upgrade the warranty or the server, and sometimes there's not a lot of difference, so we might as well get a faster server. We're fairly particular on the processors that we use, including, so this is indicating the cache size, and depending on what the server is used for, we might make a differentiation of a faster processor or more cache or whatnot. We just barely did quotes, I believe, this week. I'm sure once we have things finalized, we will be posting on it, but it's more or less going to be fairly similar to this. This was 2015, and there have been some changes. So processor, we're probably going to get a few more cores, and I know we were looking at doubling the memory. But in terms of the storage, we're reusing the same storage or waiting for Intel to come out with a 6 or 8 terabyte drive instead of a 4. Other than that, it's going to be fairly similar specs, just with a slight bump in some of the components.
Tim asks, what are you guys using for load balancing?
Load balancing, we have used Haproxy, I believe, through the entirety of the company. No, that's not true. They used to use Nginx for SSL termination, but once that was rolled into Haproxy, we currently use that for everything. Waiting to see how HTTP2 progresses in Haproxy. It is not currently available except in, I think, some developer builds, but it's been an incredibly stable system for us. We actually run, so on 2 servers, we'll run the same Haproxy with the same configuration, and then a keep live-d for a virtual IP address that can flip between the 2. So those 2 servers, you do a VIP flip. When you flip over to the other server, you can do maintenance on one. If there was one that crashed, it'll flip to the other. We also have some unique parts where we'll actually split our infrastructure. We have 2 different front-end load balancers, each with 2 instances, whereas one is dedicated for our CDN path and the other is dedicated for our public path. So we have in total 4 load balancers split between 4 ISPs, 2 different functions, and some other tricks such that if somebody was to attack our public-facing network, we can have ways of hiding behind the CDN and not allowing them to reach us directly. So that's kind of the biggest concern we have, is by running our own hardware, we are very much limited to what we can do on our uplinks, and we only run 1 gig uplinks. 1 gig is not a very large pipe nowadays. Most denial of services are approaching terabyte size. We could never really do that internally, so we have to rely on a third-party CDN to absorb some of that influx if we are ever under attack, which unfortunately does happen sometimes. Often it's just somebody in college having a bad script crawling our site. That's more or less the main denial of service that we get, but occasionally we do get quite larger ones as well.
So I'm glad Mark asked this, because if Mark hadn't asked this, I would have asked it. He says, wait, so you guys aren't upgrading to SQL Server on Linux?
We have evaluated it. In fact, when we got access to initial private builds of it, I believe it only took 4 hours for us to get Stack Overflow working, not the public side, but just a copy of the database on SQL on Linux. So it's amazing what they were able to do. It is just SQL. It's running on Linux, but it is just SQL. We've evaluated it for some different places. There's an interesting place that it may be used, which is on the Stack Overflow enterprise instances, which is basically a private copy of the software that we will let people run on premise if they're a very large organization, usually about 500 developers. We'll allow them to license the software from us and use it there. We have talked to people that would be hesitant to purchasing it because they don't want to run Windows servers. So SQL on Linux is a great path that we could support that kind of a scenario if we wanted to. But in terms of our actual infrastructure, the high availability solution there is very much in its infancy, and so we're excited to see where it goes. It's more useful for things like our open source projects. So we would love to have a time series database backed by column stores. They've been an amazing feature that we've been able to do some cool things with, and those being available in a Linux environment through SQL on Linux kind of opens the door to those open source projects that previously, if we were to tie it to a SQL Server instance, it does limit the scope of that project versus it's awesome to see it going into so many new places.
Perfect. Well, Carnegie says something. He says, great presentation. Thank you for sharing your masterful knowledge and experience. Best regards and keep up the great work. Stack Overflow is a great resource. I would agree. I would have everybody give you a warm virtual round of applause. They can follow Greg at gbrayut on Twitter. And thanks for hanging out with us today and sharing over at GroupBy. Thanks, man.